Epicenter of the giant tsunami. The epicenter of the earthquake of the exceptionally high magnitude of 9.0, is situated inside the trough as indicated between the northern edge of Sumatra and the small island of Similu, one member of the chain of islands next to the trench. Neither this trough relief reveals anything unusual nor does the comparatively moderate depth of the Sunda Trench of less than 5,000 m, the shallower sister of the conspicuous, adjacent Java Trench southeast of it. The existing records of earthquakes of more than magnitude 5.5 in the Sumatra area since 1970 have clearly shown that their great majority, including the epicenter of the giant tsunami, occurred within the shallow strip between the coastline of Sumatra and the adjacent subduction trench rim. In other words, they occurred on the edge of the overriding plate. Epicenter of giant tsunami. Java Trench. According to Abbott, the Indian-Australian plate moves obliquely toward western Indonesia at 5.3 to 5.9 cm/year, 2 to 2.3 in/year. The enormous, ongoing collision results in subduction-caused earthquakes that are frequent and huge. Many of these earthquakes send off tsunami. On December 26, 2004, 1.200 kilometers, 740 miles, long fault rupture began as 100 kilometers, 62 miles, long portion of the plate tectonic boundary ruptured and slipped during a minute. The rupture then moved northward at 3 km per second, 6,700 miles per hour, for 4 minutes. Then slowed to 2.5 km per second, 5,600, during the next 6 minutes. At the northern end of the rupture, the fault movement slowed drastically and only traveled tens of meters during the next hour. It appears that a bend or scissors-like tear in the subduction plate may have delayed the full rupture in December 2004. Deformation of sea floor and sea surface. Shulgin et al. Stated that the tectonics around northern Sumatra are predominantly controlled by the subduction of the oceanic Indo-Australian plate underneath Eurasia. The current convergence rate offshore northern Sumatra is estimated at 51 mm/year. The increasing obliquity of the convergence northwards from the Sunda Strait results in the formation and development of a number of arc-parallel strike-slip fault systems. The most significant are the Sumatra and the West Andaman fault systems, accommodating arc-parallel strain offshore central southern Sumatra. For the Mentawai fault system, recent findings suggest deformation dominated by backthrusting. Subduction of Indian-Australian plate beneath Indonesia. Shulgin et al. Subsequently, Kalmelis et al., the Indo-Australian plate is moving approximately 40 to 50 mm per year to the northeast, and the earthquake ruptured at the subduction zone boundary or interpolate thrust boundary. On the fault, the earthquake had a maximum slip of approximately 15 to 20 meters with an average slip of greater than 5 meters along the full length of the rupture. The sea floor overlying the thrust fault would have been raised by several meters. Further, velocities of displacement along 1,200 to 1,300 kilometers of the fault with at least 3 major energy bursts during the propagation of the rupture, 50 to 150 seconds, 280 to 340 seconds, and 450 to 500 seconds. Location of hypocenter of 2004.